Hello, my dear students. Welcome back to Dr. Maran's Chemistry Academy. All right. So to continue to answer the questions, right? So I'm sure all of you are waiting to know, how the dative bond or coordinate bond is formed in this molecule, right? Dimer. Now I'm going to show you how a dimer is formed between two AlCl3 molecule, aluminium trichloride molecule, and basically what we're going to do is we're going to actually draw or write the aluminium symbol in spacing between these, and what we can see here is we're going to arrange the chlorine surrounding each aluminium atom. But how we going to do that? We have to understand the type of bond that involved in forming this AlCl6, Al2Cl6. So we know that dative bond is basically the two criteria I mentioned in the previous session. One is definitely it must one particular atom must have the empty orbital, and the other particular atom must have the lone pair of electron in order to donate, right? One pair of electron. It must be one pair of electron, right? It can't be one single electron. So we're gonna see that each chlorine atom, each aluminium atom already form a 3 covalent bond with 3 chlorine atoms. So we're gonna draw that first. How are we gonna put it? We're gonna put chlorine here, another chlorine over here, and I'm going to put this chlorine in the middle. Why? I will explain later, because it's easy for me to show the dative or coordinate bond with the aluminium. Alright, so these three will be representing the central atom aluminium, and I'm going to put another 3 chlorine which is here, and the other one is here, and the other one is here. So if you see here, I arranged it the 6 Al2Cl6 surrounding it, and I'm going to actually show how the bond is formed. As you can see, this bond is a covalent bond, single covalent bond, because they each atom share a pair of electrons, truly sharing a pair of electrons. That means both atoms are contributing each other. So I'm going to put cross dot, and similarly I'm going to show you here also they're going to share one pair of electron. Here is definitely what I'm going to show you is as well they are sharing one pair of electron as well, right? So what you can see here is, right? Now another chlorine, as I told you earlier in my previous session, AlCl3 is an electron deficient compound. What is the meaning of electron deficient compound? Electron deficient compound is a compound where it lacks of electron to achieve the stable octet configuration. So in order to achieve a stable octet configuration, now the other chlorine will come here to form a dative bond. You know why? Because it already has a lone pair. Actually, if you look at chlorine, it has 3 lone pairs of electron. Because it has 7 valence electron, one of the electron for the other chlorine already formed a single covalent bond. But this chlorine will have 3 more lone pair of electron, and one of the lone pair can be used to form a dative bond. So what aluminium will do? It will form a dative bond as such. Alright, it will form a dative bond as such by contributing one lone pair electron to the aluminium. Alright, so what we're going to see, look at the other end, right? We're going to see that this aluminium will form, this is another aluminium atom which is forming a single covalent bond. How many single covalent bond? 3. Because aluminium trichloride, when we talk about aluminium trichloride, it must have a 3 chlorine surrounding each aluminium. So 1, 2, 3. 1, 2, and 3. So what I'm going to do is I'm going to actually put another, and right, this one. So I'm going to show you the electron sharing. This is actual single covalent bond, and the other part where I'm going to show you the coordinate bond by another chlorine atom. Okay, this is not electron sharing coming from both the atom. This is electron sharing coming from only one particular atom, which is your chlorine atom, because only chlorine can contribute the pair of electron. Only chlorine because it has a lone pair of electron. Aluminium don't have a lone pair of electron, but aluminium has empty orbital to receive that lone pair of electron to form the coordinate bond. So you can see this is the coordinate bond that I am talking about. So in this aluminium dimer Al2Cl6, it has total of 6 covalent bond. 1, 2, 3, 4, 5, 6. 6 covalent bond in total. 1, right? So what we can see here is out of these 6, 2 are dative bond, or what we call as dative covalent bond, or in other terms we call this as a coordinate bond. Alright, so now what we can see here is they already form a dimer, right? They already form a dimer, and then we're going to move on to the next. Again, it's going to related, okay, it's related to the dative bond as well. A white solid produced when gases boron trichloride and ammonia are mixed. Explain how the reaction occurs to form white solid. Okay, this is a very direct, simple questions as what we can see, right? How to do this? Very simple. Boron trichloride, first identify what type of molecule is that, and ammonia, right? Because this is to do with dative bond. Boron trichloride, again, it's electron deficient compound. Why electron deficient compound? Because boron is same group with aluminium, right? So it has 3 valence electron. And what we're going to see, when it shares 3 electron with another 3 atom of chlorine, it only forms total of 6 electron, but it again needs 2 more electron to become octet. Hence, it's classified under electron deficient compound. So what's going to happen here is we have to identify ammonia. Ammonia has 1 lone pair of electron, as you all know, right? So ammonia is a trigonal pyramidal shape, right? And I have already give some different separate sessions on this in terms of the VSEPR, so you can actually refer to that. So this is the trigonal pyramidal shapes where it has a 3 bond pair and 1 lone pair. In terms of geometrically, it comes under tetrahedral, but when it comes to the molecular shape specifically, it comes under trigonal pyramidal. The reason is because of the lone pair bond pair repulsion. So when there is a lone pair bond pair repulsion, the angles is narrow. So here what we can see here, instead of 109.5 for tetrahedral, it now become 107 degree, right? So this is ammonia, and our topic now is not to discussing the angle or the molecular shapes. Our question now is actually to answer how the reaction occurs to form the white solid. Now we know that it has a 1 lone pair of electron. Ammonia has 1 lone pair of electron, so it is fulfill the criteria to form a dative bond. But we have to check whether the second molecule have the empty orbital. By right, boron trichloride has empty orbital because, as I mentioned, it has 3 chlorine atom and it has another one more space that can filled up by electron. So what we're going to do is we're going to draw how a dative bond going to be formed. So what happened is, we know that ammonia, okay, NH3, and we have to show, you can either show here, okay, it shows a 2 lone pair here, and what happened, we're going to point the arrow, because arrow is representing the dative bond, to the boron, which has the empty orbital, where boron has 3 chlorine atom. All these 3 chlorine atom is actually directly bonded. That means this is a single covalent bond. They are equally contributing each other to form the covalent bond. But here it has an empty orbital where these electrons can be parked. I always call parked because they are not actual covalent bonding, but they are actually giving the 2 electron to make sure that boron trichloride is having a full contact. So this electron is parked under the shell of boron and they form the NH3Bl. So basically this is how we call this as a NH3BCl3. So this is it forms a white solid by forming a dative covalent bond. So this is how the molecule or compound is formed. All right, so I will see you in the next session for the another question discussions. Stay tuned and please don't forget to subscribe my YouTube channel to get more information and to get more updates regarding this chemistry. Thank you. See you soon.